All right, good morning, everyone.
Good morning.
Good morning.
All right, looks like Mogan is kind of blurry. Oh, there you go. That's better. Actually, I guess, no, that's Winslow, right? Okay, perfect. Well, better. That's good. Well, a little bit of blurry still. A lot of times,
It's not adjusting.
yeah, when you guys talk, sometimes it does it. So actually, that's pretty good. So how's everyone today?
Good.
Good.
All right, good to hear. Well, let's go ahead and start in on the roll. All right, Ari,
Oh, here.
Rex, Alana,
He's here. Rex is here.
Lana,
Here.
Diana,
Here.
Rachel,
Here.
Jacob,
Not here.
Taylor,
Here.
Alvin,
Here.
Athena,
Here.
Cameron,
Here.
Andrew,
Here.
Shandon,
Here.
Junior,
Here.
Hayden,
Here.
Jordan,
Here.
Ellie,
Here.
Dominic,
Here.
Brooke.
Here.
All right, so the only one I didn't hear was Jacob. So Jacob's not here. Okay. Okay, so let us see what's going on. All right, so let's see. You can all see me. You can see the board. All good? Okay. All right. Okay. So yesterday we left off with we're talking about compound inequalities and working through that. So I'm hoping that we can at least get a little bit of a start on 1.7 today. So let's see how that goes. Any questions, comments, concerns before we get started today? Okay. Well, so I'd asked you to see if you could solve this one. So let's see how we did. Let me pick somebody to answer and see if we've got that one right. All right, so Caden.
1 is less than x, which is less than. Less than
1 is less than x is less than what?
3.
3. Okay, and there we go. Great job, Caden. Does anyone have any questions on that? Anyone like me to work through it? Okay.
Please.
Oh, sure. Okay, so the first thing is to scrunch it all together. So -2 is less than 5x is less than 8. So we just kind of combine the two, the double inequality, into one compound inequality. So when you can only do that when it's an and you have the same thing in the middle. Okay, then the idea is to get x by itself in the middle. So we get rid of the 7 by adding 7 to all three parts. And so we end up with 5 is less than 5x is less than 15. And then divide by 5 by all three parts. And so then we get 1 is less than x is less than 3. Okay? All right. So any questions? Okay. All right. So now we're going to talk about absolute value inequalities. And so there's the different ones that we do are going to look like this. Really the first step is to isolate the absolute value. So like how the absolute value is by itself, okay, then we're going to be ready to go. But like on this second one, where we have other stuff with the absolute value, we're going to need to get that absolute value part by itself. So here we're going to subtract 3 and then divide by 2 before we break down the absolute value. Okay? All right. So, the way that we set it up is our first step is to take our absolute value inequality and rewrite it as a compound inequality. Now, whether it's an and or an or depends on the sign, okay? The inequality sign. So if we have the absolute value of x is less than a, then we rewrite that as an and, where it's scrunched together. And so it's negative a is less than x is less than a. That's our first step after we've isolated the absolute value part. So you take the opposite of this number over here is less than x is less than a. And so what that is so I've kind of shown you on the number line here, to say that the absolute value of something is less than a, it means its distance is less than a. The absolute value refers to distance. So I kind of think of this as like a dog on a chain. The dog can go either direction, but it can't go further. Okay? All right, now, the second part is if we have the absolute value of x is greater than a. Okay, now that becomes an or, because that's saying that this distance is greater than a units. So x could be greater than a or less than negative a. And so that's precisely the two inequalities that you get. X is less than negative a or x is greater than a. Okay? So if it's less than, it becomes an and. If it's greater than, it becomes an or. And there's two parts of it then. So once you isolate the absolute value part, then to solve it, that's what you do, is you rewrite it as one of these compound inequalities. All right? Okay, now the way to keep it straight, and this is kind of my little mnemonic device to help me remember, is if it's less than, I think less than. And that reminds me that it's an and it's scrunched together. Okay? If it's greater than, then I think greater. And then that reminds me, greater, this is going to become an or. So less than and greater help me keep that straight, which is which. Okay? All right. So here we have the absolute value part by itself. And so then the idea then is to get rid of the absolute value signs, we're going to rewrite this as a compound inequality. Now, since it's less than, think less than. So it's going to be an and, where this part, it's going to be scrunched in the middle. So we start with the opposite of that number. So negative 2 is less than, and whatever's inside the absolute value part, x minus 5, is less than 2. Okay? So now we do like we did yesterday. We try to get x by itself in the middle. So we add 5 to each part. And we got it. That's our answer. Okay? So really it's just one extra step to convert the absolute value inequality to a compound inequality. Okay? So graphically, this is just showing that it's all the numbers between 3 and 7, but not including 3 and 7 because it's not or equal to. So we would use parentheses on our graph. And then as an interval form, that's from 3 to 7. All right, any questions on that? Okay, so in this practice problem, we want to solve the inequality. So there's one extra step that you have to do here. Before you break it into a compound inequality, you have to get the absolute value part by itself. So the first thing you have to do is add 4 to each side. Okay? Then rewrite it as a compound inequality. Okay? So go ahead and try that one, please. All right, so Taylor, when you've got it.
Okay.
Negative 15 less than or equal to x less than or equal to 7. Negative 7.
All right, that's it. Great job. So negative 15 is less or equal to x is less or equal to negative 7. Okay, any questions on that? All right, great job, Taylor. Okay, so again, for the inequality symbol less than, with absolute value, think less than, and for the symbol greater than, think greater, because you've got to remember which way it's going to go, an and or an or. Okay, so this one is a greater than. So again, it's going to be an or. So what we do is we say the stuff inside the absolute value sign is either less than the opposite of this number. So 4 minus 2x is less than negative 6, or 4 minus 2x is greater than 6. So the second one is actually the same exact inequality without the absolute value signs. So you do less than, like over here. So the pattern is you do less than the opposite of this number, or x is greater than a. And now you solve each of these separately. Okay, but you're going to do the same steps. So here, again, you're solving each of these for x. So you subtract 4, and then divide by negative 2. And then remember, like we talked about yesterday, when you multiply or divide an inequality by a negative, you must reverse the inequality sign. So you're going to actually reverse both of these. And so you'll get x is greater than 5, or x is less than negative 1. And so usually, if to kind of show that on the graph, see, you've got two parts of it. So the ors usually have two parts. So greater than 5 or less than negative 1. Okay? All right, any questions on that? On the greater than ones? Okay, so once again, to start off with this one, you're going to have to add 4 to each side, then split it into the two compound inequalities, or the compound inequality. All right, so Junior, when you got it.
No, sorry.
Repeat it.
X is greater than negative 15 or X is less than negative 7.
So x is less than negative 15 or x is greater than negative 7. All right, good. Okay, and so just to give you a visual, again, this is so less than negative 15 or greater than negative 7. So again, usually the or ones are going to have 2 parts on the graph.
Why did the sign switch if you didn't multiply or divide by negative?
You mean when you set it up from the beginning? See, once we set it up, it didn't switch. What switches is when you go from an absolute value inequality to the compound inequality. So it's not really switching. I mean, this part, I guess, but that's just the setup. Okay, it's kind of like saying, if I live, let's say if I ask you where you're from, and you say, well, I'm from about 100 miles from Holbrook. Well, I don't, and then along I-40, okay? Well, see, I don't really know if you're originally from Flagstaff area or from Gallup. See, you could be from either direction. And so, because when we talk about absolute value, it could be in either direction. So if I say an absolute value is greater than 100, then you don't know which side it could be on. And so that's why so you could say, well, you could be so many miles on this side or from this side. And so the way that you say that is from 0, x is greater than a, or x is less than negative a. That gives you the distance from the origin to be a more than a unit. So that's just the setup to go from absolute value to the compound inequality. It's not really reversing the sign. That's just the setup. Okay? That's how to go from absolute value to the compound inequality. Okay? All right, thank you for that question. Any other questions? All right, so with this one, we have a 2 and a 3 to get rid of before we can break this down. So first, we subtract the 3, and so I'll get 11 minus 3 is 8, and then divide everything by 2, and so I'll get the absolute value of 3y minus 2 is less than or equal to 4. All right, now you say, okay, that's a less than, so that's an and, less than. So you take the opposite of this number and you say, okay, negative 4 is less than or equal to 3y minus 2 is less than or equal to 4. Now you solve, get y by itself by adding 2 and then dividing by 3, and that's it. That's your answer. All right. Any questions on that one? All right, now let's look at this one. Now, before I break this down, I want you to look carefully at this. And if I were to say, like I did when I solved the equations, what has an absolute value less than or equal to -3?
Negative numbers?
Actually, remember, absolute value is always positive. So the absolute value can never be less than -3. And see, if you try to, so this answer is going to be the empty set, no solution. And see, if you try to use it to break it down and say, okay, the opposite of this, 3 is less than this, is less than -3. See, this makes no sense, because 3 can never be less than -3. And so when you see something, when you write an inequality that can never be true, then that should also tip you off that the answer is going to be no solution. Okay? Come on. All right. Okay, so go ahead and try the next practice problem, please. All right, so Arvin, what do you think?
Auburn in the bathroom.
Oh, all right, so do you volunteer as tribute?
I guess.
Okay.
Is less than or equal to -1, and S is greater than or equal to -4.
Okay. Wait, say that again. S is greater than or equal to -1, or
S is less than or equal to -1, and
less
S
or
is
equal-
greater than or equal to -4.
okay. So let's graph that. Okay. So you said greater than or equal to -1, right? So that would go that way, right? And then what was the other part? What was the other part that you said? Or
It's S is less than or equal to -1.
oh, okay, sorry. Okay. So less than or equal to -1. Okay, and then what was the other part?
S is greater than or equal to -4.
Okay. So, and it's an or. So, okay, let's think about this. If what would be the answer if I were to take the or of these two graphs? Of anything that's shaded in black or red would be part of my answer. So what would the answer be? What would the final answer be? I mean, I'm not saying you've made a mistake, but we can simplify your answer.
-4, -3, -2, -1.
Okay, what about -5? Remember, what we want is anything that's black or red, we're going to count it. So is -5?
So it's all real numbers.
So it's all real numbers because every single number is either black or red, shaded. Okay? Now, is there a way that we could have figured that out from the beginning? If I look here and I say, okay, what has an absolute value greater than or equal to -3? Everything. Everything. Every number has an absolute value greater than or equal to 0. So anytime you have a negative over here when you're doing these, it's either going to be no solution or all real numbers. It's going to be either everything or nothing. Okay? So here the solution is all real numbers because every single number has an absolute value greater than or equal to -3. Okay? All right. Any questions on that? Okay. All right. So the last part here is translating inequality phrases. Okay. So sometimes these are a little tricky, and so you have to be very careful when you're reading these. So like but they're all going to translate to either less than, greater than, less than or equal to, or greater than or equal to. So if I say x is no greater than y, or in other words, x is not greater than y. So if it's not greater than, then what is it?
Menos de.
Less than.
Less than or equal to. So less than or equal to. Okay. All right. So what about this one? X is at least as large as y. So if it's at least as large as y, then could it be bigger?
Greater than or equal to?
Than or equal to. So that one would be greater than or equal to. Okay. So the first one was x is less than or equal to y. The second one is x is greater than or equal to y. Okay. X does not exceed y. All right, what would that mean?
I know.
X is less than y.
X is less than y. Could it be equal to?
No.
No.
If it doesn't exceed, that just means it doesn't pass, but it could be equal to. So this would be x is less than or equal to y. See, like if I had, if I had $20 in my wallet, and the amount of money that you have doesn't exceed that, well, you could also have $20. That just means you don't have more than me. Okay. All right. So, x is no greater than y. So what would that be?
X is less than or equal to y.
X is less than or equal to y. X is at least as large as y.
X is greater than or equal to y.
X is greater than or equal to y. And then y, how about y exceeds x?
Y
X
is
is
greater
less
than
than
x.
y.
Y is greater than x. Or you could say x is less than y. Either one of those would be. Okay. All right. Any questions on any of those? Oops. Okay, so let's look at this. This one is an inequality problem. It says express as an inequality and solve. All right, so as a test for quality at a plant manufacturing silicon wafers for computer chips, a random sample of 10 batches of 1,000 wafers each must not detect more than 5 defective wafers per batch on average. In the first 9 batches tested, the average number of defective wafers per batch is found to be 4.78. So it's pretty close. Okay? What is the maximum number of defective batches that can be found in the 10th batch for the plant to pass the quality test? Okay? So you're some kind of a quality inspector. So you're on the 10th batch. So we want to figure out how many of the defective wafers in the last batch you could have and still pass inspection. All right. So if you think of the average has to be less than or equal to 5. Okay. So if X is the number of wafers that are defective in the last batch, and then if we add that to the number of defective wafers in the previous 9, so that's 4.78 times 9. So that's the average times the first 9. And then we take that average and divide by 10, then that will give us the number of defective wafers here. And so if we take this, so why don't you go ahead and solve this? So see if you can figure out, so X is the number of the maximum number of defective wafers we can have in the last batch. So see if you can calculate that. All right, Alana, when you've got it.
X is less than 6.98.
X is less than what?
6.98.
6.98. Okay. So X is less than or equal to 6.98. Now, you can't really have, 98 100ths of a defective wafer. So in reality, that what would be the maximum number of defective wafers then?
6.
Yeah. Well, if we actually, because if 6 is the right answer, because once we get to the 7th, if we have 7 defective wafers in that last batch, then that is going to put us to an average of 5. And so really the answer is, so the real answer would be X less than 7 defective wafers, less than 7 or 6. So the maximum 6 defective wafers. Okay? So once we hit the 7th one, then we're over this threshold. And so then we're in big trouble. Okay, any questions on that? All right. Well, that's it for 1.6. So you can look for the notes, the as well as the quiz for that. Okay.
Is the quiz up for 1.5?
Yes, it is. And so then I'll be putting 1.6 up is in the next 24 hours. Okay. All right. So we just have a few minutes, but we can at least get a start here on 1.7, quadratic equations. Okay. Now, so first we're going to talk about the different ways of solving quadratic equations. Okay, and so pretty much this part of the lesson I know is just going to be review for you. But when we get into quadratic-like equations and polynomial-like equations, you might not have done that part. And so the last part of this lesson might be new. But the first part, we're going to just talk about quadratic equations. So what is a quadratic equation? Well, anytime you have a variable of 2 in your polynomial, that's going to give you a quadratic or a second degree equation. Okay. Now, I remember as a student thinking, well, why is it called quadratic? Because to me, quad would mean 4, but the exponent is 2. It's not 4. Okay. And so it was actually years before I learned that it's because the graph of these is a parabola. And so there's 4 parts of the parabola as you graph it, how it intersects with the x and y axes. And so since it's 4 parts, they call it quadratic. But we don't really worry about that too much other than the name. Okay, so there's 5 different ways that that you've learned to solve quadratic equations. And we're going to review all of these. Okay, so number 1, factoring. 2, square roots. 3, completing the square. 4, the quadratic formula. And 5, by graphing. All right, anybody need any more time on that? Okay. All right, so first we'll start with factoring. So to solve a quadratic equation by factoring, you set it equal to 0 and then factor. So like the double bubble method that we've done or using the GCF, usually those are the 2 types of factoring that we do. Now, the other kinds of factoring, like the AC method or difference of cubes, for example, if it requires those kinds of factoring, then usually we do a different method. Okay? But you have to set it equal to 0 before you can solve it. All right? So, for example, if I want to solve this, then the first thing I need to do is bring the 3x over. So subtract 3x to set it equal to 0. Okay? Now, look for a GCF. So factor out of 3x, and I have 2x minus 1. Now I set each factor equal to 0. So you say 3x equals 0, or 2x minus 1 equals 0. And then solve each of those linear equations now. So here I divide both sides by 3, and I get x equals 0. Here I add 1 and divide by 2, and I get x equals 1/2. So normally, for a quadratic equation, you get 2 solutions. So whatever your degree is of your equation, whatever your highest exponent, that's how many solutions you could have. Could have up to that many. All right? All right, so try that one, please. All right, Taylor, when you've got it.
X equals 9 and x equals 3.
9 and 3. Okay, so well, when you factor, you say what two numbers multiply to get 27, to add to get negative 12. And so that would be negative 9 and negative 3. Set each factor equal to 0 and solve. All right, great job. Any questions on that? All right, now, when we're looking to solve this one, if you remember, when you're, see, like normally you would say, okay, there's no GCF, maybe use the AC method. But remember, if you see this is a perfect square and this is a perfect square, then you can say, well, maybe this is going to factor to 3x minus 1 squared. All right, and then see, now you're going to have what we call a double root. So when we solve that, or this side, when we take the square root, or if we set each factor equal to 0, we're going to get the same answer twice. Okay, it's probably easier to see it from this way. Okay, so from the factor, when we set each factor equal to 0, we get the same answer twice. So that's what we call a double root. So when we get x equals 1/3, and it happens twice. Okay. All right, so try that one, please. All right, Tiana?
X equals negative 1/4.
That's it. Great job. Now, the way that you write a double root, okay, we're going to focus on this a lot more later, I think, in chapter 3. But like if you were going to write your answer as negative 1/4, if you put in parentheses a 2, then that means it's a double root, or it occurs twice, or we call this the multiplicity. So we say it has a multiplicity of 2. It occurs twice as the solution. All right. Any questions on that one? Anybody would like me to go over negative 1/4 as an answer? All right. The second method that we're going to go over is for solving quadratics is the square roots method. So extracting the square roots can be used with equations of the type something squared equals a constant, where c is greater than 0. And then that gives you two solutions. When you take the square root, you get plus or minus the square root of c. Okay? So radical c or negative radical c. Okay? And then, or you can write this as plus or minus radical c.
Mr. Strong, our class cut out for a few minutes, so we
Okay.
don't.
Okay. All right.
So did ours.
Yeah, I saw that. Okay, so let's say if so one way that you can tell that you can use the square roots method is if there's no middle term. There's just a squared term and a constant. So the idea is that you get the squared term by itself. So here, divide each side by 4, and then take the square root. And so this would give you x equals plus or minus the square root of 3. So you isolate the square term, take the square root, don't forget the plus or minus. Okay? Now, this also works when you have a term that's squared. Here we have a binomial that's squared. And so here if I take the square root of both sides, I'll get x minus, so it just undoes the squaring. But you have to remember to do the plus or minus. The square root is 7. And then when you add 3 to each side to solve for x, then your answer is just going to be 3 plus or minus the square root of 7. All right? All right, so let's go ahead and try this practice problem. Let's see, do we have 2 of them here? No, just the one. All right, so Rex, when you've got it.
Is it x equals 4 radical 3 over 3?
No, because when you divide each side by 3 and then take the square root, it's just going to be plus or minus 4. Okay, so you want to isolate the squared term first. Don't take the square root while the 3 is still attached. That's what's messing you up there. So get the square term by itself by dividing by 3, then take the square root. Okay? All right, now, let's suppose that I take the square root here. All right, well, when I take the square root on the left, see, it undoes the squared. But on the right, see, I have plus or minus the square root of -9. And so remember, the square root of a negative, you've got to punch out the I. And so that's going to be 3i. So here I add 1 and then divide by 2. And so my answer is going to be 1/2 plus or minus 3/2 I. So when you're doing the square root method, watch out for negatives, because then you'll always have an I in the answer in that case. All right. So try this one, please. All right, Rachel, when you've got it.
Seven.
Okay, so first divide by 5, then take the square root. And so, oh, you forgot the plus or minus, okay? Because, see, when you add 4, you'll get 4 plus or minus 3. So 4 plus 3 does give you your 7, but then you got to have 4 minus 3, which gives you 1. So you're going to have two answers on that one. So don't forget the plus or minus. You got to have both of those. All right? Any questions on that? All right, now try that one, please. All right, Junior, when you've got it.
Unmuted.
X equals -1/3 plus or minus 2y over 3.
-1/3 plus or minus 2i over 3. Great job. Okay. All right, any questions on that? All right, so we'll pick it up there on Thursday. Again, working with solving quadratics. Okay. All right, well, thank you, everyone, for working hard today, and we'll see you then.